Our sun, a giant ball of hot gas, wasn't always shining. Billions of years ago, it was just a cloud of gas and dust floating in space. This cloud, called a molecular cloud, was huge and cold. Imagine a giant cloud of smoke, but much, much bigger. Gravity started to pull the gas and dust together. The cloud got smaller and smaller. It also got hotter and hotter as the particles collided. Eventually, the center of the cloud became so hot and dense that a star was born. That star is our sun. This process from cloud to star takes millions of years. It's a slow and steady process, driven by the immense power of gravity. And that's how our sun and all stars begin their lives. Right now, our sun is in its main sequence. It's like the prime of its life, where it's stable and shining brightly. The sun is a giant nuclear reactor. Deep inside its core, hydrogen atoms are being squashed together. This creates helium and releases a tremendous amount of energy. This energy travels outwards from the core and eventually reaches the surface as sunlight. That sunlight is what warms our planet and makes life on Earth possible. Our sun has been in its main sequence for about 4.6 billion years. It will continue to shine like this for another 5 billion years or so. That's a long time. But even stars don't live forever. Eventually, the sun will run low on hydrogen fuel in its core. When this happens, the sun will start to change. It won't be able to hold itself up against the force of gravity. The core will shrink, but the outer layers will expand outwards. The sun will grow much, much larger than it is today, becoming a red giant star. It will become so large that it might even swallow up the orbits of Mercury and Venus. Earth, if it survives, will be a scorching hot wasteland. The sun will spend millions of years as a red giant. During this time, it will fuse helium into heavier elements in its core. But this phase won't last forever either. As the sun nears the end of its life, it will become unstable. It will start to pulsate and shed its outer layers into space. These layers will form a beautiful glowing cloud of gas and dust called a planetary nebula. At the center of this nebula, all that will remain of the sun is a small, dense object called a white dwarf. This white dwarf will be about the size of Earth, but incredibly dense. A teaspoonful of white dwarf material would weigh as much as an elephant. The white dwarf will slowly cool down over billions of years, eventually fading away into a black dwarf. And so ends the life cycle of our sun. From a giant cloud of gas and dust to a tiny fading ember in the vastness of space.